someone just sleeping. Question? Now let me ask you questions. So you can wake up. Yes?
What is the difference between the leading strand and the lagging strand?
Yeah, leading, as the name implies, just continues to be elongated by DNA polymerase II. So that's the leading strand. Right? Once the RNA primase is placed in there, it will continue to elongate until it finishes. That's the leading one. The lagging strand, it is like lagging, it is like step by step, right? So that is creating these Okazaki fragments, okay? Because this one, they're going in the opposite direction. Here, once it opens, you will have here the 5' to 3' end. That's how DNA elongates, the DNA polymerase III, right? On this end, you have the 5' to 3' end, right? So we'll add a primer, elongate. But let's say here, it open here first. So you add this primer, elongated. Then open more over here, add another primer, elongated. Continues to open as primer and elongates. Here, it will open more, you will add another primer here to elongate.
Would the leading strand first be a lagging strand and then it becomes a leading strand?
That's what you're referring right here, right?
Yeah.
How in this side it is the leading strand, but here it is the lagging strand. That's because that is on the other side of the replication fork. So here what you have, let's say here is the 5' to 3' end, right? Here, after half of this replication fork, it is the opposite. Here, once it opens, this one is 5', that's a 3'. Here is 5', 3'. Okay?
So it doesn't become, it just is, right?
It's just based on the orientation, right? It's not that it becomes or changes, but on the other side of this replication fork, okay? So, notice here, okay? This is the replication fork, okay? This part right here, that will become the leading strand, okay? Once you have big replication fork, this will continue to elongate. This one right here, you will add a primer and then elongate, right? Primer, elongate. Notice that it opened more. So now here, we'll add another primer, elongate, add another primer, elongate. That is lagging. Same thing here, right? First, add a primer, elongate. That's that one right there. It opens more, fragment, elongate, primer, right? So notice that halfway, because this 5' to 3' end. This one continues to elongate. Continues to elongate. Here it was 5' to 3' end, right? Same thing, 5' to 3' end. So on this side, once you have here 5' to 3', once it opens up, it needs to go in this direction again. Okay? So depends on which side of the replication fork you are. If you are on this side of the replication fork, here's your lagging strand. If you are here on this side of the replication fork, here's your leading strand. Sorry, leading strand. If you are in this side of the replication fork, here's your leading strand. If you are here on this side of the replication fork, here's your leading strand. Depends on which side you are. But notice that easy to identify the one side that continues to grow. That is your leading strand. There is no need for more Okazaki fragments. The one that it has multiple Okazaki fragments, that is your lagging strand. Okay? Does that answer your question? All right, but key point, okay? This picture right here will be on your exam where you have to determine or identify each of these key players. On the exam itself, there will be like multiple questions asking you which one is the enzyme that does this, which is the enzyme that does that. Next Tuesday.
Wait, what?
This coming Tuesday. This is the exam.
Shut
No,
That's really quick.
What?
We just finished in 3.
We did just finish.
Wait, are you serious?
No, yeah. Check your syllabus.
Oh no.
Okay, let's take some break. Count to 5. 3, release. Inhale, exhale.